We're going to talk about local file inclusion, and we're going to see how we can convert local file inclusion into log poisoning. Okay, the very first LFI stands for, I'm going to use different color, local file inclusion, and it is a vulnerability that hits web applications, so it's classified as web vulnerability. All right, so how it happens. So basically, let's take an example. This is a URL, example.com. And as you can see here, guys, there is index.php, the page that's being loaded. Okay, and we have an ID parameter. Now, usually the ID parameter controls or has values that controls which web page gets rendered. So in case the ID equals to 1, page 1 gets rendered. Equals to 2, page 2 gets rendered. Now, basically, this is all happening in the background for the regular user or the average users. But you as a pen tester, you might be asking yourself, what if I change the value here? Okay, so in local file inclusion, we try to let the parameter load up a file system. So in Linux systems, there are many sensitive files. One of them is the password file. The password file holds the user data of the user of the Linux system. It doesn't hold the passwords. Remember that the actual file that holds the passwords or the hashes is etc, or is a shadow file located in etc directory. So you want, instead of loading these pages, we want to let the ID parameter load up the password file. So instead of supplying 1, we use the appropriate tools to intercept the request, and then we supply the location of the password file. Now, if the application doesn't filter the user input, meaning if it doesn't check on the user input, ideally it will check the input if it equals to a value within an array of values. Say the application expects you to supply 1, 2, 3, 4, or it only accepts these values to load certain pages. Now, a secure application will check on the user input. So we will load up here, or we try to load up the password file. So we supply this instead of 1, and the application will check if this entry exists within the certain or with the current array. If it doesn't, it's going to throw 404 or forbidden. That's the expected behavior of a secure, healthy application. But if it is vulnerable to local file inclusion, so it's going to say, oh, I have an open heart, I accept all the gifts. So it's going to say, oh, you want to load up etc password? Here it is. So the ID parameter here doesn't check on the user input. So the problem is in the code. That's why we call this application vulnerable to LFI, local file inclusion. We include a file system in the GET request to retrieve the contents of this file. Now remember that the file will change depending on the operating system. So here we know that after the information gathering phase, we know that the application runs on Linux. So usually Linux, the password file is Linux system is under this directory. Now, what if the operating system was Windows? So in Windows, the application or the web server software will be different. So in Windows Server, there is the IIS. It is Internet Information Server. So basically, it's the software that's used to host web applications. Now, IIS uses different extension for the web files. So if the web application uses IIS, you will see the index or the files on the web server or the web page, holds different extension. Usually it's ASPX. This is an indication that the web server software is IIS. So it means our target is a Windows system. So if you want to execute local file inclusion, we want to load a file within the system. So we're going to take into consideration the file system structure in Windows operating system. So here we try to load up the SAM file that contains the passwords or the hashes of the users on the system, including the administrator. So we include this path instead of etc password. So remember to take this into consideration, the operating system type, before you try to execute local file inclusion. Okay, now back here. Now there is a chance that the target machine, it could be a Windows and running Apache at the same time, because there is a package called the XAMPP which lets you guys host a web server running Apache, MySQL, and PHP. So if you see Apache as the web server software during an enumeration phase, don't conclude or don't immediately assume that, oh, this is Linux system. Apache can also run on Windows. Okay, now let's demonstrate the scenario of this video, HackTheBox Toxic, which is a web challenge. In this web challenge, we demonstrate local file inclusion, and we had a chance to jump from LFI to log file poisoning. So why do we transform from LFI to log file poisoning? Why wouldn't be just why would it be enough to just load file systems back to the web browser? Because sometimes certain files we're looking after, their locations is unknown. So if the location is unknown, our capability in exploiting the local file inclusion or going further is limited, because technically we don't know where is the file we want to load. So if we don't know the file, we're not going to be able to load up the file unless the application is vulnerable to directory traversal, and that's a different subject. We're not going to talk about this in this video. Additionally, log file poisoning allows you to execute system commands. So how do we go from LFI to local file poisoning, log file poisoning? So remember, guys, that log files contain a wealth of information, such as it could contain the URL requested, it could contain the user agent, the timestamp, and the HTTP request type. Now, the main target when we want to conduct log file poisoning is the user agent. So instead of the log file loading the user agent of the user, we try to replace the user agent with a system command such as ls or dir in case of Windows. And that's the scenario of this application here. So in this web application, or in the scenario here, HackTheBox Toxic, there is a PHP code, okay, that controls a web page. The PHP code contains an if statement. Now in the if statement, it checks if the user is an existing user through a cookie check. So if it exists, it's gonna just load up the web page, and if it doesn't exist, it's gonna here, create a cookie using base64 from plain text. So that's the original form of the cookie, and the constant part is the page that's being rendered. So the cookie here assigned to the user contains one important part is the page being loaded along with the location of the page. Now in this scenario, that's the spot of local file inclusion, because usually the spot of conducting local file inclusion is the URL. Here it is not in the URL, it is in the cookie, because the cookie reveals the web page being loaded. So if we just intercept a regular request from the web browser to the web server, we're going to be able to intercept the cookie. If we decode the cookie using base64, we're going to be able to see the plain text form. Now we see the URL, or we see the page being loaded. Now we change this to the file we want to reveal, which is the flag. But the problem is we don't know where is the flag. Remember, in the local file inclusion, if we don't know the path of the file, we're not going to be able to load the file, because this is not an RCE, this is local file inclusion, simply loading up files. If you know the location, you're going to be able to reach it. If you don't, you're not going to be able to load up anything. So we need to know the location of the flag. That's why we change the strategy. So we go from LFI to log file poisoning. Log file poisoning requires us to find us the location of the log file. So we know from intercepting the request that the web server is Ngnix. In Ngnix, in Ngnix, the log file is located under var log Nginx access log. That's the location of the log file. So first we load up this file by changing the index with the location of the log file, and we'll be able to see the log file and then determine the next action. So that's the source code here. And remember that this is a challenge that you can access, guys, from HackTheBox Toxic. It's a web challenge and the files are attached. Okay, going back here to the challenge. As you can see, guys, there is an if statement that checks on the cookie. If it doesn't exist, it's going to create a new cookie here using the PHP session ID and use base64 to encode the page object. Now the page here, it's a class and page model, and it has an attribute named file that points to the the file being loaded or the page being loaded. Now that's how the cookie is created. It contains this attribute, the file. Now, how we're gonna do here? We're going to go to the web page and use perp suite. Intercept is on. Okay, so this is it. As you can see, guys, this is the cookie. Now we want to change this. This cookie points to the file. If we decode this using CyberChef, so from page 64, this is the cookie. Now we're going to change this. So from or to page 64, instead of index, we're going first to load up the access log. So var log ngnix and then access.log. So we're going to copy this cookie and go to the web application. So I have them here. So we're going to go to application, highlight this and send it to the repeater because we're going to play with it more than one time. Send. And as you can see, we are able to see the log file. Right now, ignore this. I'm gonna tell you guys how I did it. So that's the log file, and as you can see, there are different parts of the log file, including the request. It contains many entries sorted by the most recent. So the most recent one is here. This is the most recent request, and the oldest one is this. Let's take an example. Take a look at this. This one. As you can see, it contains the IP address, the request method, the URL, the path, and the user agent. That's the target. Now, how we can inject the user agent? It's very simple. We sent a simple request. We can now intercept it. That's the user agent here. We're going to change this to a simple PHP one-liner. Okay, so one-liner that executes a system command. Remember that our target is to reveal the location of the flag. So what we want first to see, it could be in the current directory we have. So first we check the current directory. So we use a PHP one-liner. Okay, so let's change user agent here and say PHP system ls, and we wrap it up. Okay, send this now. Now we want to check if this is successful. So instead of the user agent, we're gonna have the system command execute in the log file. Scrolling down, as you can see, we are able to see the contents of the directory. In the contents, we have the flag file. So what we're gonna do now, we want to load this file. So we go back to the cookie plaintext form and we use the file name, the flag name, and now effectively we have the new cookie. So if you go back and change this to the original request, because the original request doesn't have the user agent tampered with. So we're gonna use this and we're gonna forward, and as you can see, it loads up the flag. So that was it. Definitely, guys, you can execute further system commands. So guys, that was it, and obviously I'm gonna see you later.